Hello, today we're going to learn about simplifying radicals. All right, simplifying radicals. All right, so radicals are these signs here. It's like a square root sign, right? So think about it for a second. Why is this true? Why does a square root of 25 equal 5? Well, the square root of 25 equals 5 because 5 times 5 gives us 25, which is that same number that's under the radical. Right? So the square root of 25 equals 5. So when we're doing the radicals, we're looking for two numbers that multiply together to give us that number. And we want it to be the same number, right? So that means we're looking for the same number. What number times itself will give us back that original number? So think about this. What is the square root of 50? Well, if I open up Desmos and I type in the square root of 50, that gives me a big long decimal. I get 7.071. Let's write this down up here. 7 point, what was it? 071. And then it kept going on forever and ever and ever and ever and ever, right? So that means the square root of 50, there's no whole number times itself that will give you 50, right? So this means that 7.071 dot 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 that kept going on. If we multiplied that by itself, times itself, then it would give us 50. But we can't do it with two whole numbers. And what that is called, that decimal that goes on forever and ever and ever, that's called an irrational number. And irrational decimals are crazy. We don't want to keep the decimal, but we also need to be precise in our answer. So that's the reason why we have to simplify radicals. So instead of converting that crazy decimal answer, that crazy long answer, we can simplify the radical or the square root. Okay, so parts of a radical is we have the number that's underneath the radical, and that's called the radicand. Radicand. That's the number that's underneath, right? That's called the radicand. All right, this number here is called the index. If there's no number there, we know that it's the square root, but you guys have seen this one because we've used it on Desmos before where you see the cube root, right? So that would be an index of 3. In Algebra 2, you'll see the index of 4, right? So that's called the index. So we have the index and we have the radicand. And then this symbol is called a radical symbol. Totally radical, dude. All right, so that's square root of 50. We got that big, long, crazy decimal, right? So what we want to do, so we don't get that big, long, crazy decimal, is we want to simplify this radical. So what we have to do is we have to break 50 down into numbers that we know multiply into 50. So 50, I see it ends in a 0. I know I could always times that by 10. And I know 5 times 10 gives me 50. 5 is a prime number, so I can't break that down anymore. 10 I can break down, though, because 5 times 2 gives me 10. So I'm making a factor tree here of numbers that multiply together to give me 50. So what I want to do now is I'm going to rewrite my factors underneath my radical sign. And I only want to write the prime numbers. So that would be like these 5s and this 2. I don't want to write that 10 because at 10 we broke down more. So we're just looking at the bottom of our trees. So that means I have 5 times 5 times 2 under my radical. And if I multiply this, 2 times 5 is 10. 10 times 5 would be 50. I get back to that 50. All right? So to simplify this, what I can do is I can pull out groups of 2. Take out groups of 2, because that would make a perfect square. So if I pull out a group of 2, I see I have 2 5s here, I can pull that out of my radical. So I'm going to pull that out of my radical, and what's left underneath, like this 2, is going to stay inside the radical. And this is the square root of 50 simplified. It's 5 times the square root of 2. And to show you that it's the same, I can plug this in on Desmos and see, right? So square root of 50 got me this number here. If I do 5 radical 2, look at this, 7.07106781187. It's the exact same number as this, right? So 5 square root 2 is another way of rewriting the square root of 50. All right, let's say I had the square root of 72. All right, so let's try it first. Let's clear out my calculator, and I'm going to do square root of 72. See if it is a whole number. Nope, I get a decimal. So I get a decimal, that means I have to break this down. So what times what gives me 72? Well, 8 times 9 gives me 72, so I can write 8 times 9. 8 I can break down more. 2 times 4 will give me 8. And 4 I can break down more because 2 times 2 would give me 4. 9 I can break down more because 3 times 3 would give me 9. So now I'm left with all prime numbers on the bottom. So I'm going to rewrite this with all my prime numbers. So I'm going to have 2 times 2 times 2. I have 3 2's. 1, 2, 3. And I have 2 3's. So times 3 times 3. So now what I can do is pull out my groups of 2. So I see there's one group of 2 and one group of 3. So this group of 2 can get pulled out, and this group of 3 can get pulled out. So that means I'm going to be left with 2 times 3 on my outside, and on my inside I'm left with a 2 there. So this number on the outside, I can do 2 times 3. 2 times 3 would give me 6, and then that square root of 2 would stay square root of 2. And that's my answer. I can't simplify it anymore. And to check my work, I can put it in Desmos. I already have the square root of 72 there, right? So now on my next line, I can type in 6 square root 2. And look, I get the same decimal answer as I did before. That square root of 72 and this 6 times the square root of 2, I get that same decimal. So I know I simplified it correctly. All right, this example, I have 2 the square root 150 x squared y. All right, so this one's a little different, right? Because we have x's and y's here. Okay, the first thing I want to do is I want to worry about this 150. So I can put that in my calculator and see if the square root of 150 is a whole number, gives me a whole number. Square root of 150, no, it's not. It gives me a decimal. So that means I have to break this down. So that 150, I'm going to need to break down and say, all right, what times what gives me 150? Well, I know 50 times 3 would give me 150. 50, 100, 150, yep. 50 I can break down to more. I know 2 times 25 would give me 50. And 25 I can break down more into 5 times 5. So now I want to rewrite this to square root with all my prime numbers. So I have a 2, I have a 5, I have another 5, and I have a 3. All right, I also have these variables here, right? I have x squared, so that means x times x, and I have a y. So now I can go through and pull out my groups of 2. So I see I have a group of 5, so that 5 I know I can pull out, and I have a group of x's that are the same, so I can pull that out. So on my outside, I'm going to have 2, because that's this original 2, times 5, because I pulled out a group of 5's, times x, because I pulled out a group of x. And underneath, I'm going to be left with this 2 that stay under there, didn't have a partner. I have a 3 that's going to stay under there because it didn't have a partner. And I have a y that's going to stay under there because it didn't have a partner. So 2 times 5 would give me 10. 10 times x would just be 10x. And underneath I can do 2 times 3, which would be 6. And 6 times y would be y, 6y. And that's my answer. I can't simplify it anymore. 10x times the square root of 6y. All right, there's 2 practice problems here. Try these 2 on your own. See how you do. Go ahead and pause that video, try it first, unpause it when you're done, check your answers. All right, hopefully you paused the video and you did it on your own, and here are the 2 practice problems. So square root of 200, I did 2 times 100 because I know that gave me 200. 100 I can break down more, 2 times 50 gives me 100. 50 I can break down more, 2 times 25 will give me 50. 25 I can break down more because 5 times 5 gives me 25. And now I have nothing but prime numbers. So I have 1, 2, 3 2's and 2 5's. And remember, I'm looking for groups of 2, so I pulled out my group of 2, I pulled out a group of 5's, so that gives me 2 times 5 on my outside, and on my inside I'm left with that 2, because that 2 there does not have a partner. So I multiplied 2 times 5, that gave me 10, and that 2 just stays underneath, so it'd be 10 times the square root of 2. On this example over here, I broke down 45 into 5 times 9, because 5 times 9 gives me 45. 9 I could break down more, 3 times 3 would give me 9. So I rewrote it, 5 times 3 times 3, because those are my prime numbers. I pulled out my group of 3, and I pulled out my p's, because this says p squared, So the p squared means there's two p's, so that's one group of p. So on my outside, I have a group of 3 and a group of p times the square root of 5. So 3 times p would give me 3p, and that's my final answer, 3p times the square root of 5. All right, so that's how we simplify radicals. We're going to practice this a lot in class after spring break, but good for you for learning it now, and I hope you do well. See you later!